Let's explain a little bit more about the population formula as to how the t is working in this formula. So let's say you have a basic population model where the birth rate is 10%, the death rate is 5%, and the initial population is 100 rabbits. And the question is asking, what is the population of rabbits at the end of year 3? So basically here we have our basic code. And so just to begin, I'm gonna just comment this out, but I'm just gonna say expand this t. So t is 1 through 3, so it's 1, 2, and then 3. So those are gonna be our iterations. T is gonna be 1, then t is gonna be 2, and in the third one, t is gonna be 3. So let's begin. First, let's put our variables here. Let's say p of t and p of t plus 1. Those are variables. Okay, so let's begin. So when we go through the first loop, so we come here and we say, okay, well, t is equal to 1. So on the first loop, t is going to equal 1, which means that here t is going to be 1, so it's going to be p of 1 plus 1, which in reality it's p2. So with the first iteration, when time is 1, p of t plus 1 is p of 2. So p of 2 is going to equal to p of t, which again, in this particular scenario, in the first iteration is going to be 1, so it's going to be p of 1 plus, let's abbreviate this, birth minus death times p of 1. So what this is going to be is basically p of 2, and actually let me do it underneath. So what this is p of 2 is going to equal p of 1, which we have defined right here, 100, plus the difference between the birth and the death rate, which is going to be 10% minus 5% is going to be 5%. So we're going to have 0.05 times p of 1, which is 100. So let's do these. And so what this is going to be is basically, we're basically taking the initial population and then we're calculating 5% over this, which is the net growth, is the difference between the birth and the death. And so that's going to be 5% of 100 is going to be 5. So it's going to be 100 plus 5 is going to be 105. So when time is 1, p of t is p of 1, and p of 2 is going to equal 105. Okay, so now let's go to the second. We're done with when t is 1. So the next iteration, t is going to be 2. So in the next one, when t is 2, p is going to be p of 2 plus 1. It's t plus 1. So this is going to be equal to p of t, which in this case, t is 2. So it's going to be equal to p of 2 plus birth minus death times p of 2, because it's p of t, the original formula. So in the second iteration, t is 2. So this is going to be basically p of 3 equals to p of 2, which we know is a 105. 105 plus 0.05 is basically 5% of p of 2, which is 105. So this is going to give you a decimal, like 5.25 maybe. And so what you want to do is round it up because you're dealing with the rabbit population. So you'll have to insert a floor function here, or you can put it at the end. But to expedite, we're just going to assume that this is going to be basically rounded up. So 105 plus 6 is going to be 111. So when time is 2, when t is 2, p is p of 2, and p of t plus 1 is p of 3. and this is going to be 111. Okay, so now we're going to do our last iteration when time is 3. So when time is 3, p of t plus 1 is p of 3 plus 1 because time is 3 now. And p of t is going to be p of 3 plus birth minus death times p of 3. This is p of t, and t is 3 now. Okay, so this is going to be really p of 4, which is what we're after. P of 4 is going to be equal to p of 3, which is 111, is the last population that we calculated. And then the difference, which is going to be 0.05 times p of 3, which is 111. And so this again, we're going to have to round up. So this is going to be 6 again. It's going to be 5.55, something like that. But we're going to round it up. And so 111 plus 6 is 117. So when time is 3, p is p of 3. P of t in this formula right here is p of 3 because time is 3. And then p of t plus 1, p of 3 plus 1, is going to be 4. So it's p of 4, which is going to equal 117. So at the end of the problem, if you ask the computer to give you p, what is p? It's going to give you all the values of p that we have. And the values of p that we have starts with p1 because p1 was defined here. And then the next one we have is p2, p3, and we also have p4. So the values are going to start at 100. So 100 is p1, p2 is 105, p3 is 111, and p4 is 117. So if you want the computer to give you the population at the end of year 3, when time is 3, you will need to ask for p of 4. So if you ask for p of 4, the computer is going to give you 117, which is that. So the reason basically with the why, for example, if you have calculate the population at the end of year 3, this is why you have to ask for p of 4. It's because your population begins at p of 1. So with the first iteration that you do, you're calculating p of 2, and then p of 3, and then p of 4. So you're starting really one behind. And so if it's asking for what is it when you're done with this loop, then really it's going to be when time is 3, p of t plus 1 is going to be p of 4, which is 117.